The new riegl VQ820G and VQ880G are two topobathymetric LiDAR sensors which are applicable for, let's say, the survey underneath the water surface. And within the last 5 years of our existence, we made large efforts on the development and the research on the joint topobathymetric point cloud analysis. And here at Geo 2015, we're presenting in Stuttgart our largest project we have had in the past. It's the survey of the Lake Constance, pretty close here to Stuttgart. And the size of this project is over 18 terabyte of raw data, and in total we are speaking about 20 billion survey points underneath the water surface. The sensors we are operating are the VQ820G and the VQ880G, and the VQ880G is the next former step in topobathymetry LiDAR laser scanning. The new developments on the VQ880G are the joint forward and backward looking of the sensors. So within one scan strip you have now the possibility to get a clear penetration and representation of the topography and the bathymetry from a look forward and backward. We have a much more higher pulse repetition rate of 550 kilohertz. We are now operating the system, and due to adjustable beam divergence and also laser power setting, we are able to adjust the survey to the conditions we want to capture within our data. When we started this joint research project in 2007, the main focus was on the European Water Framework Directive. So let's say the waters everywhere on Earth, independent whether there's a regulation or not, are the most changing areas we have to handle and we have to manage, and the problems we have to manage in this area for the future. And therefore a new sensor technology was needed to get proof of data, to have the possibility to go there for research analysis and have the chance on good and high quality data to look for solutions for let's say the maintenance, the restoration, the problems we have to face in futures on or at our waters. We're here looking at a river stream in Bavaria. It's called the River of Loisach. Our work to do within this project was, next to the survey of the bathymetry of this river, to handle afterwards the point cloud and go for hydraulic, morphologic and ecologic modeling on the data set. So here you see a joint data set. It's existing out of the point cloud and the hydraulic results within the river stream. So the darker blue you can here see are the water level calculation based on a certain amount of water which needs to pass within this, and the hydraulics and everything was done on this joint topobathymetric point cloud. And the data and the final results will be used for river restoration, for flood care, for calculations on flood prediction and stuff like this. That's one of our newest items for the Geo 2015. Next to our LiDAR scan, we capture spectral RGB images and thermal data within one survey process, but we also capture 360-degree videotaping of the entire project area, so afterwards the client can have a real visual access to the data we have captured by these goggles and the possibility to go for a 360-degree review. And also the point cloud afterwards is handed over within this VR equipment, and he can walk through the point cloud in 360 degree and can go wherever he wants in his point cloud. Let's say the VR reality for the future says keep it as simple as possible, and therefore we step to a solution just using a smartphone, a high resolution display within a smartphone to represent our data set. We developed a new software which is able to convert the point cloud into the form the goggles need to represent the 360-degree point cloud within the goggles. So it's just a slide out here. We have here a simple cell phone, a simple smartphone, and this is one of our 360-degree reviews. And now we are just jumping over to another one here together with a 360-degree visual access to the point cloud. So if you bring it together, you have a 360-degree and three-dimensional look and walk through your point clouds. So you just move your head up and down and you can see everywhere what the sensor captured during the survey campaign. It's a new file format called F5. It's coming out of the HDF5 file format, out of the Supercomputing Association in the United States. And this file format, for example, is also used for the calculation and the modeling of galaxies. And we just use this high efficient data format to go for point clouds. Within this, we are talking about, I think it's about 18 kilometers of river stream we had to capture. And the total size of this file, I think, was about 2.4 gigabytes we are here representing.